Okay, we're going to look at the project now, what the functions class is going to do over the next weekend, and give you an idea. We're going to plot the equation, or come up with an equation of bridges. So you're going to pick your favorite bridge, and you can see here my favorite bridge is not London Bridge, but it's Tower Bridge. And if I look under Wikipedia, I can find all sorts of things for Tower Bridge. Here you can see a cross-sectional view of Tower Bridge. And what I plan to do is find the equation of this part of the bridge here. That's what I'm going to do for my project right now. Let's just get rid of this. There you go. Play the video on. There's not much else, but a bit of information down the bottom here. We'll see in a minute about the bridge, which helps us do something. But all this is on Wikipedia, so you choose your favorite bridge and you find the equation of that bridge related to any point on there. Okay, so we'll look at that right now. And here is my famous London Bridge. So I'm going to take this part over here and I'm going to try and find the equation of that little arc there. It looks like a parabola, and I'm going to treat it as a parabola and see what I can do from there. Okay, so here is the bridge as we saw it in Wikipedia. Let's just zoom in here. Don't think we can, but we'll try to. So as we zoom in here, we can see there's interesting sort of facts here. There's one here that says the clear headway at high water when the leaves are down. So that's basically when the bridge is down, you've got clear water headway. That means the distance from the water to the bridge is 29 feet and a half at its maximum, that number. And then at the sides here, it's 20 feet. So that gives us an idea of how to draw or how to come up with an equation for this bridge, the right-hand side, left-hand side of this bridge. So what we're going to do, we're going to choose a point on this bridge where we're going to draw the axis as 0, 0. And this point here is going to be my point of 0, 0, because you're already given some lengths. We know that this length here is 100. This length here is 270 right across here. And we know that this length in here, if we look very closely, is 70. So all the way across here, I know it's going to be 100 plus the 70 plus the 270. And that helped me map out my x-axis. My y-axis will come down this way. And this point here will be, this line here will be the x-axis. So now the graph that I'm looking to draw, with this blue line being what I'm trying to find the equation of. So if we look closely here, we should see that the height of the bridge is 141 feet here. And we know that this distance from here to here is not exact, but it's about 29 feet. There's probably a small foot in there that I can't take really account. So 141 plus the 29 makes 170. So I know that this distance all the way up here, all the way from there to there, is 170. 29 plus the 140. How far in are we? Well, let's have a look. We've gone 100 plus 70. So this point here is the point negative 70, comma 170. That will be one of the points on my graph. The next point I want to find is perhaps this one here, which looks like it could be the vertex. Well, I know it's 100 to there, 70 there, 170, and another 135 there. So this point here is negative 135, negative 235, negative 305, comma, Now what's that height up there? It's going to be 29, isn't it? Positive 29. So I've already found 2 points. And what I think I've found is the vertex. The vertex is 135 plus the 70, 205. So it's negative 305, comma, 29. So if I was to put this into quadratic form, I know that this is the vertex form I'm looking for. And HK, H is this value, K is that value. How do I find A? Well, I find A by substitution. So this is what we want you to do. We want you to find a bridge. We want you to map it out, find the cross-sectional view of it, put an XY coordinate on it in a very interesting place. I've got it on the water here, underneath the main central part of the bridge. And I want an equation of this part of the bridge. This is the only curved part of the bridge. There's no point finding the equation of these parts because these would be just x equals y equals vertical numbers. Okay, good luck. This is due on next class next week. So Monday, December. Let's have a look. So the first is 3rd, 2nd, 3rd, 4th, 5th is when this is due. All right, from everybody. We're a bit behind on doing this project, so it has to be in by everybody. Do it on your computers, do some graphs, do some work, and then submit it for marking. Thank you very much.